The late Mariam Mirzakhani was an Iranian mathematician. In 2014, she became the first woman to win the Fields Medal, the highest award in mathematics. Sadly, she died of breast cancer a few years after that award, at the age of 40. When Mirzakhani was in school, math was not her favourite subject. In fact, she actively disliked it. Her first memory of ever really enjoying mathematics was when she was surprised by the elegance of a solution. Her brother told her the famous story of Carl Gauss, the 18th century mathematician. In the story, Gauss's schoolteacher asks his students to add the numbers from 1 to 100. So 1 plus 2 plus 3, all the way to 100. The teacher was looking to buy himself some time and peace, but young Gauss disturbed that peace. He had a solution in a few minutes. Mariam's brother explained the solution by looking at the numbers like this. Then, adding the pairs which all give the same number 101. As there are 50 of these pairs, the calculation is simplified to 50 multiplied by 101, or 5050, and much quicker than adding all the numbers individually. Mariam described her enjoyment and delight at this surprising solution and how it influenced her shift to loving this subject. What do other mathematicians feel about the relationship between math and surprise? Let's hear what more of them have to say. Thomas Britz is a university lecturer in math and the editor of the online math journal Parabola. He spends a lot of time thinking about how to get others to understand and find beauty around them through the lens of mathematics. In 2018, he gave a TEDx talk called The Mathematics of Emotion. The talk looked at the recent neurological studies about math and emotion, particularly the emotions associated with beauty. He says our brains reward us when we recognize patterns, whether this is seeing symmetry, organizing parts of a whole, or problem solving. He also said when we spot something deviating from a pattern, that's when there's a touch of the unexpected, our brains reward us once again. We feel delight and excitement. Let's look at a simple everyday example. You might have heard how humans instinctively find symmetry beautiful, including the symmetry of human faces. However, a feature that disrupts the symmetry in a surprising way, such as a beauty spot, only seems to add to the beauty. Britz gives another example. The same idea can be seen in music, he says. Patterned and ordered sounds with the touch of the unexpected can have added personality, charm, and depth. Many mathematical concepts exhibit a similar harmony between pattern and surprise, elegance and chaos, truth and mystery. Surprise is a key element to finding beauty in math. Andrew Wiles, one of the most well-known modern mathematicians, talks about the role of surprise in a conversation with fellow mathematician Hannah Fry. As a child, Wiles was gripped by the story of Fermat's last theorem. For those who don't know it, it's a charming story. And the book, Fermat's Last Theorem by Simon Singh, will give you all the juicy bits. Here's the gist. In 1637, the French mathematician Pierre de Fermat was in the library working on math when he wrote this mathematical statement in the margin of his exercise book. There are no three positive integers x, y, and z for which this statement is true. X to the power n plus y to the power n equals z to the power n. He also wrote in the margin, I have a truly marvellous proof of this proposition, which this margin is too narrow to contain. In the hundreds of years since that, mathematicians tried in vain to find this elusive proof. When Wiles heard the story, he was 10, and he was hooked. He decided he would find the proof, and years later, as an accomplished mathematician, still obsessed with Fermat's last theorem, he found it. It wasn't the elegant solution Fermat thought he had found. It is widely agreed by mathematicians that Fermat might have been mistaken in his idea, but it was a proof that shook the world. What had captured 10-year-old Wiles's attention was the surprising simplicity of a statement that had perplexed mathematicians over centuries. In the conversation with Fry, Wiles describes the experience of walking down a path to explore a garden by a great landscape architect when a breathtaking vista suddenly comes into view. Wiles said this feeling was equivalent to what happens when you experience mathematical beauty. He says elegance in mathematics is this surprise element of suddenly seeing everything clarified and beautiful. Tadashi Tokida is an extraordinary mathematician and math communicator who delights the viewers of his videos with weird and wonderful and surprising math. His philosophy of math is to play with it, and he uses toys to do so. I like to be surprised, he says, and I like to be proved wrong. So we have seen that mathematicians time and again equate mathematical beauty to surprise, or at least to beauty containing surprise. And that surprise is often the thing that motivates mathematicians to explore further. Have you ever experienced surprise while working on math? Let's do some math together while thinking about emotions. You might have seen some of these before. If you have, think about where the element of surprise lies and how students can experience it. Let's start with a number puzzle. You can use a calculator if you like. The purpose of the puzzle here is for you to experience the surprise, not practice addition and subtraction. In the classroom, you might not allow calculators. Write down a 3-digit number whose digits are in decreasing order, so 532 but not 572. Reverse the digits to create a new number. Subtract this number from the original number. With the number you now have, add that to the reverse of itself to get a final result. Now repeat that process with a different 3-digit number, and another, and another. Did you get a surprising result? What questions did it bring up? What do you want to explore? Although I said the purpose of the puzzle was to experience surprise, which would then lead to further mathematical explorations, you might have another purpose for your students, which could be practicing 3-digit addition and subtraction. What a delightful way to practice it, rather than doing pages from a math exercise without any surprise or delight embedded within. Stephen Storgartz, mathematician and author of the book The Joy of X, talked about one of his favourite proofs. Before we look at it, have a play with this structure. Add the first 3 odd numbers, 1, add 3, add 5, and note down the result. Add some other strings of consecutive odd numbers starting from 1. Write down your results. Do you notice anything about them? Pause the video, it's worth it. You might have noticed that the thing about your results is they are all square numbers. A surprising result indeed. Why is it so? What's the relationship between strings of odd numbers and squares? It's not really very obvious, unless you look at it in a different way. If you write the numbers as a series of little squares laying in an L shape, you will see that stacking these L shapes together forms a square. Every next odd number can be stacked in this way, thereby making a bigger square each time. And voila! There's a lovely proof, surprising in its simplicity and its visual nature. If you enjoyed that, there are some lovely surprising proofs to explore in the classic book by Roger B. Nelson called Proof Without Words. Have a look at the activities section of this course. I've included a math magic task, a task for teachers to do together, and other surprising tasks. I hope you enjoyed doing these math puzzles and being surprised. You can use these ideas in your classroom. In the next lesson, we will look more closely at how to teach with surprise, including looking at more tasks and how surprise is present, though often hidden, in school math curriculum.